Hello students, welcome to TS Curriculum. Next exercise is exercise 1.2. Express each of the following numbers as a product of its prime factors. So, first one is 140. 140 can be expressed as 2 into 70. On the right side I have given the how to express it. 2 into 70, and 70 can be expressed as 2 into 35, and 35 can be expressed as 7 into 5. If we the prime factors are 2 into 2 square into 5 into 7. What are the prime numbers first? Like it will be 2, 3, 5, 7, 11, 13. These are the prime factors, right? So we are expressing this as the product of prime factors. Until we get the prime factors, we are going to do this problem. Next bit is 156. If 156 can be written as 2 into 78. 78 can be written as 2 into 39. 39 can be written as 3 into 13. That is 2 square into 3 into 13. Further we cannot multiply anything. So 156 can be expressed as a prime factorization 2 square into 3 into 13. Third bit is 3825. It can be expressed as 3 into 1275. 3 into 1275. 3 into 1275 can be expressed as 3 into 425. And 425 can be expressed as 5 into 85, and 85 can be expressed as 5 into 17. Next bit is 5005. 5 into 001. 5001 can be expressed as 7 into 143, and 143 can be expressed as 11 into 13. And all the four we can, if we check, those are all the prime factors. Next, coming to the second bit, that is find the LCM and HCF of the following integers by the prime factorization method. First bit is 12, 15 and 21. If we check 12, we have to do it by prime factorization method. We have to multiply it until we get the prime factors. For 12 it is 2 square into 3. For 15 it is 3 5s are 15. For 21 it is 3 into 7. And what is LCM? It is lowest common multiple. What is the lowest common multiple? So LCM will be in the 12 it is 2 square. What is the LCM? Lowest common multiple means highest powers of all prime factors present. Highest powers of all prime factors present means, what is in 12? We have 2 square into 3. 2 square into 3, we have taken 2 square into 3, and we have taken 3 only once, because in 15 also 3 is there, in 21 also 3 is there, which is common. That we are not taking, only 3 power 1 we are taking. And 5 is 5 power 1 and 7 power 1. If we multiply all those things, we will get 420. And HCF means what? Highest common factor. Highest common factor. Lowest powers of common prime factors. Lowest powers of common factors means in 12, 15 and 21 the common is 3. So lowest power means 3 power 1 is the lowest power. So the highest common factor is 3 among all these things. Coming to the next bit, 17, 23 and 29. Here in 17, 23 and 29 all are prime factors only, and we don't have any common factors. So HCF will be 1. In LCM, if we check, all are distinct only. That means different. There are no common multiples. So if we multiply that one, we'll get 111,339. We take the product of all prime factors, none are repeated. Next, coming to the third bit, that is 8, 9 and 25. 8, 9 and 25. 8 can be written as 2 into 2 into 2, that is 2 cube. 9 can be written as 3 into 3, that is 3 square. 25 can be written as 5 into 5, that is 5 square. LCM is equals to 2 cube, 3 square, 5 square. That is because it is the lowest common multiple. So in 2 cube we don't have any common in if we see here, we don't have any common multiple here, all are different, so we have taken. For example, if there is 2 cube in 9 is equals to 3 square, it is there. If it is 2 cube, then we will not take it, we will not repeat it. But here it is different. 2 cube, 3 square, 5 square, all are different. So if we multiply all these things, we will get 1800. And here if we take HCF, and it will be 1, HCF will be 1, because there are no common multiples, there are no common factors. 2 is different, 3 is different, and 5 is different. So there are no common prime factors out of these 3 numbers, so HCF will be 1. Next, coming to fourth bit, that is 72 and 108. 72 is equals to 2 into 2 into 2 into 3 into 3, that 2 cube into 3 square. So for 108 it will be 2 into 2 into 3 into 3 into 3, 2 square into 3 cube. Here HCF means what? Lowest powers of common prime factors. So lowest powers of common prime factors means lowest powers. What is the lowest powers of common prime factors? In the first one, it is 3 square is the lowest power. In the 108 one, we will have 2 square is the lowest power. So, and what it is, the lowest powers of common prime factors. In 72 we have 2 cube, and in 108 also we have 2 cube, but we have chosen 2 square because 2 square is lowest than 2 cube. Similarly, in 3 square and 3 cube, both are same. It is 3 square, it is 3 cube, but out of these two, which one we have to choose? 3 square we have to choose, because the power of 3 square is less. So HCF will be 2 square into 3 square. If we multiply this, we will get 36. LCM will be highest powers of all prime factors present. What is the highest powers of all prime factors present is 2 cube. In the 72 we have 2 cube is the highest power. In the 108 we have 3 cube, and we are not taking common. So 2 cube into 3 cube, that is 8 into 27, that is 216. And the next bit is 306 and 657. So 306 can be expressed as 2 into 3 into 3 into 17, 2 into 3 square into 17. And 657 can be expressed as 3 into 3 into 73, 3 square into 17. So here the common is 3 square is common here. So HCF will be 3 square, that is 9. And LCM will be 2 into 3 square. Only 1 3 square we are taking here. 17 into 73. If we do multiply all these things, we'll get 22, 3, 8. Next, coming to the next bit, which is check whether 6 power n can end with digit 0 for any natural number n. For a number to end with digit 0, it must be divisible by 10. It must have both prime factors 2 and 5. So if it has to be divisible by 10, it must have both prime factors 2 and 5. So 6 power n is equals to 2 into 3 whole power n. It can be expressed as 2 into 3 whole power n. That is 2 power n into 3 power n. So if it has the base has 5, then only it will be divisible by 0. So, but in this case we don't have 5 at all. The base does not have 5, but it has 2 and 3. Therefore, no power of 6 can ever end with 0. if we check 6 power n, how many numbers if we take 6 power 1 is 6, 6 power 2 is 36, 6 power 3, like that. If you do n number of things, you will not get 0 because it cannot be expressed as 2 into 5, so it will not end with 0. For any natural number n, 6 power n will never end with 0. Next, coming to the next question, that is explain why 7 into 11 into 13 plus 13, 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. So first case, 7 into 11 into 13 plus 13. If we check here, 13 is common here. If we take 13 as common, 7 into 11 plus 1. 13 as common, 7 into 11 is 77 plus 1. 3 into 78. It can be expressed as a product of two numbers greater than 1. So it is composite number. What they are saying here is, if it is a prime number, suppose, like if 2 is a prime number, it is, what is the definition for prime number? 2 is a prime number because it is divisible by 2 and itself. 2 ones are 2 and 1 twos are 2. So it is a prime number. And if we check 3 can be written as 3 into 1 and 1 into 3. That is the definition of prime numbers. But here it can be expressed as 13 into something. It is not expressed as 13 into 1. So we can say that it is a composite number. Similarly for the next one, 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. If we multiply all these things, we'll get 5040 plus 5, 5045. And if we want to divide it, multiply it, if we want to check this 5045, 5 into 1009, it can be expressed as a positive product of two numbers greater than 1. It is composite number. So if we could express 5 into 1 alone, then we can say that it is prime number. But we are not expressing as 1. It is 5 into 1009. So it is expressed as a product of two numbers greater than 1. It is composite number, because composite number definition is it can be expressed as product of two numbers greater than 1. Every positive number can be expressed as a product of primes. Next, coming to the fifth question, that is how will you show that 17 into 11 into 2 plus 17 into 11 into 5 is a composite number? Explain. So first this can be written as 17 into 11 into 2 plus 17 into 11 into 5. If we take 17 into 11 common from both the things, we get 17 into 11 into 2 plus 5, 17 into 11 into 7. So it is a product of 3 integers greater than 1. It is not 2 also, it is 3 greater than 1. So it is a composite number. As per the definition of composite number, it is a product of 3 numbers, so it is a composite number. Coming to the sixth question, that is what is the last digit of 6 power 100? Given 6 power 100. So if we check, for 1, 6 power 1 is 6, 6 square is 36, 6 cube is 216, 6 power 4 is 1296. Like that, if you check for n number of things, like 6 power 5, 6 power 6, 6 power 7, if you keep on multiplying, you will end with 6 only. Every power of 6 ends with 6. So the last digit of 6 power 1 n is always 6 for any natural number n. So the last digit will be 6. The last digit of 6 power 100 is 6. Thank you.